Okay, welcome back everyone to our ACT prep. And today we're going to talk about science, some strategies that you can use on the science section of the ACT. And we'll look at a few questions that you did on your practice test. The science portion of the ACT includes content from those classes you see there. Don't worry if you haven't had all those classes. The questions in the ACT you can answer from the data that you're given in passages, tables, charts, and figures. There are really three types of questions that you're going to see. Data representation, where you interpret graphs, tables, and illustrations. Research summaries, where you have to analyze experiments, and those are written about in passages. And conflicting viewpoints, which are alternative theories and hypotheses. And I'll tell you now, when you see that passage, you'll have one conflicting viewpoint. When you see that, it's recommended that you save that for last. Typically, that is the most difficult passage in the science portion of the ACT. All right, don't be intimidated by the subject matter. You're being tested on your ability to read graphs, interpret experiments, and problem solve. You're not being tested on how much content that you remember from science classes. It will help you to know some of that content, but all the answers for the science portion of the ACT can be found in the passages or the tables, charts, and figures that will be in the test. You might have to infer at times, but again, all the information that you need will be in the passage itself or the charts and tables that go with it. The answers are usually part of the passage. I just said that, graph or chart. Take time to study the charts and the graphs. Look at the labels and titles to understand what they show or what they're trying to illustrate, and read the question carefully and use the provided information to answer. Also, quickly read the passage to determine the subject and main points. I would not spend a ton of time trying to read in detail the passages. You want to read over those, get a general idea of what the passage is about. You may want to annotate a little bit, but you cannot annotate a huge amount. And I'll talk about your time constraints in just a minute. But you don't have time to read those and annotate every little thing. Just read through it quickly. If you see some key words that you want to underline or circle, do that. But you're going to have to move fairly quick. You cannot spend a lot of time. Most of the answers will be found in the charts, tables, or graphs. The questions will usually refer to a specific chart, graph, or table. And this is imperative. This is very important. When the question says in figure 1 or in table 1 or in experiment 2, it might give you one data set to look at. And that's what you need to go to. Normally, it will be one data set. There may be two, possibly, but it will say in experiment 1 and in experiment 2, or it'll table 1 and figure 2. It will tell you where you need to be looking. So it's important that you can get overwhelmed with some of the data sets that you'll see. But remember, read the question. If the question's referring to one certain data set, that's where you need to be looking. If it's referring to more than one, then you're going to have to look at more than one. But that question will oftentimes guide you. And so let that be your guide so you do not get overwhelmed with all the data sets. Be sure to look at the figure that is referenced in the questions, what I was just saying. This will help you save time and narrow your answer choices. There are 7 passages with several sets of data for each passage. The questions at the beginning of each passage are easier, usually requiring you to only look at one of the data sets to get the correct answer. The final questions for each passage are more difficult and usually require you to look at multiple data sets and or infer from those data sets in order to get the right answer. Don't get stuck on these. Move on to the next passage if you need to. With 7 passages and only 35 minutes, you're going to have to use your time wisely. So just like in math, when we talked about the math section, the first 20 questions are the easiest. The middle 20 questions in math are a little harder, and the last 20 are the most difficult. When you're doing the science passages, each passage, the first couple questions will be easier. Get those right. You've got to get those right. Usually that's pretty black and white, cut and dry to a right answer. The questions, there might be 5 questions, there may be 7 questions to a passage. Those later questions in each passage will again be more difficult. Don't get stuck on those. If you need to move on and come back. And like I said earlier, it's recommended that you do the conflicting viewpoints passage last, but don't be worried about, well, what does that look like? What if I don't know which of the passages is the conflicting viewpoint? Don't worry. Just do them in order if you need to. But if you recognize the passage as a conflicting viewpoint and you want to skip it and come back, again, that's recommended. All right. So, like I was saying, 7 passages, 45 questions total, 35 minutes. That equals 5 minutes per passage and about 52 seconds per question. So you'll need to use your time wisely. Again, those first 3 questions or so in each passage, really make sure you get those right. Again, those first questions in each passage are going to be, I won't say easy, but they're the easier ones. And like I said, typically the answers are right there. There's not a lot of inferring that you have to do to get answers in the first couple questions in each passage. All right, looking at the first passage in the science portion, and this was on page 1 of the science portion in your test book for the juniors that are out there. And in this passage, you were reading about blood pressure. And there are 3 data sets that you see. You have table 1, you have table 2, and figure 1. So what I did when I was looking at this passage, I read quickly over those couple of paragraphs just to have an idea of what I was looking at. I didn't spend a lot of time there. So then, and we're going to look at question number 3. Question number 3 is a pretty easy question, but we had about, I think, half got this question wrong. So let's look at that. If you read the question, which statement best summarizes the results of experiments 2 and 3? So we're going to have to go back and look at 2 sets of data, experiments 2 and 3. So we're really, it can throw you off a little bit. If you look at experiment 2 there, and that goes with table 2. In experiment 3, there's figure 1 that goes with it. And if I just look at these charts, and in general terms, if I look at the pressure in table 2, and I can see as pressure goes up, the amount of stretch of a cell also increases, and the time to regain the original shape for a cell also increases. And then it talks about loss of elasticity in a cell, and the loss also increases. So very quickly I can see that as pressure goes up, all those other things go up as well. And if I look down quickly at figure 1 in experiment 3, I look over there on the left side is oxygen capacity, and then the bottom is pressure. And so very quickly I can see that as pressure increases on that bottom axis there, then oxygen capacity also decreases. So I have a pretty good idea of what those two figures of table 2 and figure 1, what they're trying to tell me or what they represent. So I come back here and I look at the question again, and I'm going to just read the different choices I have. So first, red blood cells that have a high loss of elasticity lose their ability to carry oxygen. That could be correct. Red blood cells that have a low loss of elasticity lose their ability to carry oxygen. And we know that that kind of contradicts what we were looking at, because a low loss of elasticity, that's good. That means the cell wasn't under a lot of pressure. And then C, as blood pressure increases, the red blood cells' ability to carry oxygen and the time to regain their original shapes also increase. Now, this is tricky because part of that is true, but part of it is not true. So looking again, as the blood pressure increases, we know that a cell, based on the data we just looked at, this ability to carry oxygen will decrease. All right. But the part in there about regaining their original shape, that time, it will increase. So part of C is correct, but part of it is not. So be careful. And the same thing with D. Part of D, that choice is correct, but part of it is incorrect. As blood pressure decreases, the red blood cells' ability to carry oxygen and their time to regain their original shape also decreases. That is not true. Like I said, as blood pressure decreases, yes, the cell can carry more oxygen, but their time to regain their shape, it will decrease. So be careful with C and D. The correct answer there is A. Okay, now let's look at question 5, same passage. Based on the data in table 2 and figure 1, so we're going to just look back, table 2 and figure 1, which is what we were just looking at, same data sets there. Which statement is most correct concerning a person who is suffering from hypertension? Hypertension is just another word for high blood pressure. And it tells you there in the parentheses, blood pressure greater than 175. So I'm going to read each of those choices. The oxygen capacity of the red blood cells will increase as they are under more pressure. We know, if we look at that data at all, we know that that's not true. So we can mark that one out. The majority of red blood cells will not be able to carry oxygen as they are stretched beyond their elastic limits. That one I'm not sure about, so I might put a question mark by B. C, the red blood cells will regain shape more quickly than the red blood cells of someone with normal blood pressure. We know that that's not true. Someone with high blood pressure, as the cells stretch, we know it takes more time to regain their shape the greater the pressure. And then D, red blood cells will be able to hold less oxygen than the red blood cells of someone with normal blood pressure. That one to me is like flashing. Yes, that's me. Choose me. So I'm going to choose D as the right answer for question number 5. All right, looking at the next passage. This passage was about static seating model and the dynamic seating model. So to me, this one was the conflicting viewpoint, because it's talking about two different possible ways to seed clouds to cause precipitation. Now, this one, as I went over it, I had a little trouble with it because as I was trying to read the questions, look at the data, I was trying to go through it too quick, and I realized I needed to read more in detail the passage to find out what exactly the static seating model and dynamic seating model, what they were. And again, it showed me that the differing viewpoint does take a little more time because I took a lot more time looking at this one and reading about it than any of the other ones. So question 9, let's look at it. Question 9 is on page 5 of the science section for you. which summarizes the dynamic seeding model. And if we look back, we'll look at the choices, and we'll look at the dynamic seeding model, that little graph there, that figure 2. And so we can see that, and we can see the water mass, how it increases at the 10-minute mark there, and it holds kind of steady and then starts to decrease around the 40-minute mark. And then, so we can read our choices here. The stimulating cloud growth with ocean moisture. Well, I didn't see anything about ocean moisture in the passage when I read it, so I don't think that's probably the right answer. Injecting the cloud with additional water vapor. The passage also did not mention injecting the cloud with water vapor. It mentioned injecting the cloud with a chemical. Providing substances to which frozen water vapor can adhere. I read something about that, but it didn't go with that particular model. And then increasing cloud height by producing updrafts with chemicals. If I go back, that was in the dynamic seeding model, I believe, in the second or first or second paragraph there, I read about the updrafts and the airlift in the cloud as rockets were released. And so to me, that is the right answer. So I would select D, and again, D is the correct answer. And so you have to be careful, because C, you may have remembered reading something about that, about water vapor and substances it could adhere to. But again, I think that was in the other model. All right, look at 11. Using figures 1 and 2, which statement best describes why there would be increased support for static cloud seeding? Go back, looking at figures 1 and 2, and be careful, because it's a little tricky. If you really have to look at the numbers on the left side there that represent water mass, because in the dynamic seeding model, it's only going from 0 to 400. And in the static seeding model, it's going from 0 to 1200. So you can see that using the static seeding model, you're able to increase the water mass a great deal, a lot more than you can in the dynamic seeding model. And the time is about the same. That's pretty much consistent in both models. But if you only looked at it and you didn't look at the numbers over there on that left side, the water mass, you might not realize that the static seeding model is really produces the most water mass, a lot more than the dynamic model, about 3 times as much. So keep that in mind. All right, so which statement best describes why there would be increased support for static cloud seeding? A, it produces larger clouds. That's tricky, because you might say, yeah, well, it water mass, but we didn't say cloud. It doesn't say water mass there. It says clouds. So don't get fooled by that. It produces clouds with longer lives. When we looked at that, it was about the same time. It produces clouds with higher amounts of frozen precipitation. Again, we're talking about water mass. And then D, it produces clouds with greater increases in water mass. There you go. That pretty cut and dry. That's black and white there, simple. That's one that we've got to get correct. So I would choose D for number 11, and that would be the correct answer. All right, we'll look at some more science later in the week, but I hope this helps. And remember, when you're talking about the science, time is not your friend, because you've got 35 minutes to complete the 7 passages with 45 questions. You've got 5 minutes per passage. Use your time wisely. Skip tougher questions. And if you're at that last minute and you're going to have to fill in bubbles, pick one. Pick A, B, C, or D. Pick one of those and fill in your bubbles that you're not going to be able to finish. Now, don't do that with 5 minutes left. 5 minutes left, you still have a lot of time. I'm talking like with 1 minute left to go, and you got, let's say, 8 blanks, then you're going to pick one bubble, A, B, C, or D, and you're going to fill in the remaining questions you did not get to with one choice. So I hope that helps.